our seminar today. All kinds of fun stuff that we have up front today. Things, wheels, 3 wheels, 4 wheels, 2 wheels, all kinds of wheels today. Okay? So you're all here because it's the exciting event wheels we're going to talk. I want to remind you next week, Melinda White will be talking about some of her work that she did at the Ames National Lab with respect to reduction of metal oxides, microwave ovens. If you want to come out for that, and I'll hear what she has to say for that. And the week after that, we have some other exciting stuff coming up. I think some computational chemistry for pharmacologists and stuff like that. So a lot of good things on the syllabus for our seminar series. If you don't know what it is, just go to latu.edu/science seminars, and that will give you the full schedule there. All right? So, I want to remind you that we will have lunch after the seminar, and it will be in the Joyce room. So if you have follow-up questions for the students here, or for Karen Rispin, if she's around, there she is. Okay? I'm sure that they'll be happy to entertain those questions then over food. If you're a commuting student and you don't have a meal plan, don't worry. I've got the dean's card right here in my pocket. It's got $1 million on it. So I think that we can handle a few of you if you want to join us for lunch and you don't have a meal plan. So please do. All right, without further taking up your time, let's welcome our Wheels team.
Good morning, everyone, and thank you for coming here today to listen to us talk about wheels. I am Justina Ajanga, a biomedical engineering major here at LeTourneau, and with me is our team lead, Ben Jonah, and other members of Sonia Souza Science, Karen Ngulu, and Brendan Simpson. We also have Melanie that should be coming in later. Our faculty lead for this project is Mrs. Karen Rispin, and this semester we've also been opportune to have our new biomedical engineering professor, Dr. Sasaki, who is also, we've been working with Tyler Johnson, who is a master's student here at LeTourneau. He's the guy that makes sure that our equipment's in working order and they're good for us to go. Here is us over here. So, LeTourneau started the Wheels project in 2010 with the help of Ms. Rispin, and we partner with a School of Disability Kids in Kenya called Joytown, and also with Bethany Kids, which is a rehabilitation that work with these kids. So far, LeTourneau has taken students to Kenya for this research about 4 times, so about every summer since 2010. And they do this research in Kenya for a period of time in the summer, and then come back. The team is comprised of students ranging from the freshmen all the way to seniors, as well as different majors like biology, chem bio, kinesiology, and engineering. Like you can see the wheels here, we're all about the wheels, but also we're also concerned about the condition and durability of the wheelchairs that we work with. Here in America, the roads are good, and most disabled people that are in need of wheelchairs usually have powered wheelchairs. But in places like Kenya or some low-resource setting areas, the roads are rough, and most of the kids will need assistance pushing the wheelchairs. Some of them cannot self-propel. So in our research, we try to enable these children to have functional wheelchairs. But more so, our biggest goal is to help improve their life by giving feedback to the manufacturers of these wheelchairs. We get feedbacks from clinicians, wheelchair users, and orthopedics, just pretty much people that have experience with wheelchairs. And we take it to the manufacturers and say, hey, this wheelchair has this problem, this condition needs to be fixed, and that way they'll be able to improve the wheelchairs for better functioning. Here are some of the studies that we've been involved with. About a month ago, we were in Nashville, Tennessee, doing a test retest validation in the International Student Symposium, and Sonia is going to talk to you more about that. And like I said earlier, we do a lot of studies in Kenya. Karen will tell you more about it, and Melanie has been in Kenya, so she's going to tell you about all the fun and activities that they do there as well. If you notice around Glasgow, you've seen this Rosses, which kind of signify like the rough terrain areas in low resource settings. This semester we've usually been focused in data collection of pushing studies, and Brendan is in charge of that, and he will tell you everything that you need to know about that. And Ben Jonah went to Kenya last summer, and they did a bunch of studies, including the curve studies. So he will tell you more about that. So sit back and enjoy.
As Justina said, my name is Ben Jonah. I'm a senior kinesiology exercise science major, and I was part of the team that went to Kenya this past summer in May 2014. And there we did skill studies, as well as working also at the secondary school. But I was on the primary school team where we did the skill studies. We did, skill studies consisted of two 6-minute tests, the smooth and the rough ground tests, and then 4 3-minute tests consisting of the figure 8, wheelie, and transfer tests, as well as a curve study. So the curve study is what I was focusing on in terms of looking over the data. And so it is a sub-study of the overall skills tests, and what the curve test is, it is a 3-minute test over a 3-meter long course. And so we marked out the course there. You start at one point, go a certain distance up the curve, down the curve, and then the same amount of distance before the curve. The curve in Kenya was 9 centimeters high, and you can kind of see there, it's kind of like a little man cover there, and so they went up that and went back down it. And so we also had each researcher next to the test while the test was being conducted. You can see I'm right there, clearly marked out. And we also each had a translator there to help us out. And so my job, or anyone conducting the test's job, was to keep track of the distance. So we did this through counting laps. And since we knew the distance, we knew the laps, we were able to figure out the overall distance of each participant for that particular test. We each had a heart rate strap around the participant's chest that recorded on a watch that they were wearing. So the categories I were able to keep track of while doing the overall skills test, but particularly the curve study, was heart rate, physiological cost index, which is calculated with the distance and heart rate, the distance category, and then we each had each participant, with the help of the translator, fill out a visual analog scale, which will kind of be referenced to later in the presentation. And so those were just the categories that I was looking at, particularly what I was focusing on the curve study. And so for the overall skills tests, while we were in Kenya last summer, we only did 2 chairs, but for the sub-study and the curve testing, we had 4 chairs. We had the motivation, we had the whirlwind, free wheelchair generation 2 chair, and the Hope Haven kid chair. We had 30 participants do the testing. The testing was, or the chairs were randomized, so the order was all random. But not all 30 participants were able to complete the tests, but we had each participant go out there, had the heart rate strap all strapped onto them, and we had each participant at least try to do the testing. And so there you kind of see the Hope Haven chair had the least amount of people completing the test, and we had the motivation and the whirlwind, we had the highest amount of people able to complete the testing. And so with this, we were only able to use the ANOVA analysis on the people who completed the testing in all 4 chairs. And so we only had 11 people completing the tests in all 4 chairs, so 33%. That is what we were able to use the ANOVA analysis on. And what we found through the ANOVA analysis is that the motivation and whirlwind chairs outperformed the free wheelchair generation 2 chair, and all 3 chairs outperformed the Hope Haven chair. And we found this in the physiological cost, the distance traveled, and the participant feedback, which is the visual analog scale. And you kind of see down here, we found through the p-value that there was a significant difference between the chairs in those 4 categories right there: the distance, the physiological cost index, the subject response, and the heart rate. And so what we do with all this data is we write papers and we go to present it. And so myself, Mrs. Risman, and Lisa Ham, we're currently going through the process of writing an academic paper on this sub-study, the curve study. And this has also opened up the WHEELS program in general. It's opened up a lot of doors for me as I'm a senior. I'm looking on to continue my education, And through that, I've been applying to different master's programs. And one of the programs actually asked if I would like to go up to Red Deer, Alberta, Canada, and present at the Adaptive Physical Activity Symposium. And so that's where I was a couple days ago, presenting there, this curb study, a poster there. So through that, able to meet a lot of awesome people who work with recreation, either in parasports or Special Olympic type sports. So able to meet individuals who work that for the major cities up there, and also for Paralympic Sports Canada. So that was something that was really a cool experience, and that's something that if you're in undergraduate research or kind of on the edge of whether to do it or not to do it, I would highly encourage you to do it, as it can open up a lot of doors on whether you want to continue in research or continue medicine or anything else. You can, this opens up a lot of doors. So now I'll pass it on to Sonia, who will talk about ISS.
Hi guys, my name is Sonia. I'm a sophomore biomedical engineering, and I'm going to talk a little bit about what we did in the International Seating Symposium. That was during snow day, so we missed all the snow. And I've never seen snow, so. During the ISS, Melanie Dudmer did a paper session, a paper presentation of a study she did here and in Kenya, comparing the ease of pushing two wheelchairs using large resource settings. And just to make a parenthesis in here, they did it with the help of a local church here in Longview, and they pushed two different wheelchairs in a normal gravel ground. Like, it's not a describable surface, and this was a precursor of the study that Brennan is now doing, and he'll talk about it later. We also did the validation of the wheelchair component questionnaire for condition, and by test retest reliability validation, and I'm going to talk about it too. This is us setting up. We had the opportunity to have a table in the exhibit hall of this big conference, of this international symposium, and as you can see, there's a lot of big companies that have wheelchairs and just exposing their technology to the PTs, physical therapists, and occupational therapists that they attend to the conference, and they want to see what is new so they can prescribe it to their patients. So we had an opportunity to be here, and we were pretty much just going around and catching people and talking about our research and what we do to get them to do our questionnaire and help us validate it. And this is the ladies that went there just for the picture, and this is our table. And now I'm going to talk about the WCQC. It was developed by previous wheelchair wheels project, and for clinicians to rate the condition of a specific wheelchair regardless of the design. So we don't care right now if it's suitable or if it's well designed for the low resource setting. We care if it's functional or if it's broken or what breaks in a period of time. And this is 70 questions rating the different parts of the wheelchair, and at the end they will rate the overall wheelchair and give us our comments and feedback on it. So now I'm going to do kind of an example of what they did. We went there and catch them and told them a little bit about Wheels Project and what we do, and then they came to our questionnaire. We read them an information letter about what is it, the questionnaire, and then we will give the instructions to them to rate each of the components of the wheelchair. This is one of the wheelchairs that we use, and they will make a grading marking anywhere along the line, and the letter grades are just for them to see kind of like what type of grade they're going to give, but they have to grade anywhere along the line. And for example, this one rate the seat, so a clinician will come and just like feel it, pat it, see if the covering is dirty or if it's worn out, if it has scratches, and then they'll put a mark on it. So in here, they rate it a C+, and then they put their comments on it, what do they think about it, and they will go on and rate all the parts, the wheels, the foot rigging, the wheel casters, the wheels overall, the push rings, and at the end, they'll rate the overall wheelchair, and this is kind of like an average of what do they think the wheelchair is, and then they'll give, they give us the poor and good features of the wheelchair. And for test retest reliability validation, we needed 40 clinicians with experience. It could be physical therapists, occupational therapists, seating specialists, or engineers that have experience with wheelchairs that will come and do the questionnaire once, and then come back again at least a day later and assess the questionnaire a second time. And we will try to measure the consistency between the first time they did it and the second time they did it. Try to measure how much their answers to the questions change. And this is some of the pictures of the clinicians making the questionnaire. And at the end, we will give them a Starbucks gift card just to thank them for their time. This is the data collection. The vertical marks were measured. It's a 100-millimeter line, and it will measure from 0 up to their tick mark, and that was uploaded along with the comments to the spreadsheet for statistical analysis. So if we go back to our example, we will measure it, and then, for example, this was 55 millimeters, and then we will upload that into the seed part of the spreadsheet, and then their comments, the cushion is worn, the covering material is thin, and it has holes. We will put that in comments because the comments are very important for us because they describe the grade that they just gave to this part of the wheelchair. And our goal at the end is to get this questionnaire validated so we can give feedback to the manufacturers and say, well, your wheelchair has had an average grade of a C-, having very weak caster wheelchairs that will break in certain amount of time. So we think that will be very helpful for them because here in the States, all the manufacturers, they have those data because they do tests on it and they get feedback. But in this type of wheelchair for low resource settings, there's no data of this stuff online, or they don't have it. So we're giving them feedback to know what breaks in what amount of time. And this is us doing data collection. And for results, we were able to successfully get enough data for the test-retest reliability validation, and preliminary results confirm that we got all these three. That is inter-rater reliability, that measures the grade of agreement between all the raters that took the test. And then the test-retest reliability, it measures, as I said previously, the consistency among only one person between the first and the second time they did it. And the sensitivity, because it could tell the difference between what type of wheelchair it was measuring, because we did 3 different wheelchairs, one that was very badly, one that was okay, and one that was the better one. So the test could also tell the difference between which type of wheelchair we will measure. And just to be cool, Boyce, that it was one of the guys in the Frontier Senior Design that went with us. He was wandering around and going to catch people, and he found this person, and he saw that we had the LeTourneau logo, and he said like, oh, I went to LeTourneau, and he's an electrical engineer, and he graduated in '85. So it's very cool just to see that people is actually our education and our degree in LeTourneau is really worth it, and we can do cool stuff with it. And he works in quantum, and they developed this power wheelchair, which is really, really cool. And this is a picture of us with his wheelchair. So just to know that we can find LeTourneau people everywhere. And I'm gonna hand it off to Brendan.
Hey everyone, I'm Brandon Simpson. I'm a freshman biology pre-med major, and I'm kind of in charge of the pushing studies this semester, which is the main study we're doing. It's in process right now. We haven't finished yet, but I'll kind of give you a brief overview of what it is and what's happening. So the purpose of the study, we're trying to evaluate these 2 wheelchairs, the Motivation Modigo and the Hope Haven Kid Chair. We're trying to see the ease or difficulty of pushing these 2 chairs over rough and smooth surfaces. What we're looking for is just the pusher's data on this. So like in the United States, if someone is completely immobilized, they'll probably have a power wheelchair because we have the ability to get that technology. But in low resource settings like Kenya or anywhere else, someone's probably going to have to push that wheelchair if they can't propel themselves, and that terrain is going to be rough most of the time. And so what we're trying to see is, over these rough and smooth terrains, how hard it is to push one of these, like, say this wheelchair is easier getting over the lip of a rough terrain, and that one, say the caster wheels just don't roll right or something like that. That's what we're looking for, to see what's better on each chair and what doesn't work. And also, what we're looking for is how much energy the pusher is putting out. So we're going to be using these units, which I'll talk about in a minute, to measure their heart rate and how much oxygen they're consuming while they're performing these different tests. doing is we're doing 6 different tests. So you've seen those long boards underneath the senior design projects out there. That's our simulated rough design. I'll talk more about that later, but that's one of the tests. And so in each wheelchair, they'll go over the rough surface, they'll go over the smooth surface, and they'll walk on the rough and smooth surfaces in each chair. And then we'll compare that data later on. So how are we doing this? We're going to measure the volume of oxygen consumed, heart rate, distance traveled, and participant feedback. So in each of these tests, the order is randomized, so there's no favor of which chair will be used, and it's just kind of mixed up to keep consistency. And so each track is 30 meters long. The Rust track is 21 meters by itself, and there's a room for turning on each end. So they'll start at one end, they'll go down, and that starts the time at 6 minutes. And it goes, and we'll measure the last 4 minutes because that's when the heart rate kind of balances out at the peak of the exercise, and we kind of measure and see the last 4 minutes of that data on each test. So they'll do 6 minutes on the rough track, 6 minutes on the smooth track, and 6 minutes on the walking track on each chair. And so in these chairs, we have a 50 kilogram dummy, which is kind of to represent an average person that would be in these chairs using them. They have a proper center of gravity, so there's a machine thing that they built in the Frontier lab where they kind of test it, and they can lean it forward and lean it back, and they measure to where that is. They put it into a formula, and that kind of tells them where the center of gravity is so that it's properly centered on these chairs. And Russell Thurman, who just made these out of the kindness of his heart, did that for us, so if you see him, give him a high five or something, because he's awesome. This is Austin McCaslin. He's doing one of the tests in this chair. And so if you see someone doing it, that's what it is. So the Rust. It's a rough surface simulator. What it is we found that gravel in the past is just too inconsistent. We found that sometimes it has a smooth surface, and over repeated times it's just going to smooth out and not be as rough as it was at one point. And so what we found is Jay Duvall, for his thesis at the University of Pittsburgh, he made a roughness standard scale. So he went out and he saw brick surfaces, concrete, really rough concrete, and gravel, and he put measurements between boards to see how rough that is. And so what he found is that a 2-inch gap between these two boards is equal to a gravel surface. So the reason we use this is because it's consistent between all these tests. It's not going to change, and the surface is going to stay the same through all these tests. And what these Russes are comprised of is 10 segments, each consisting of 16 boards that are 5 inches wide and 36 inches long, and connected to 10-foot PVC pipe by a 9-inch inner tube. And so we also have spacers in here to keep the 2 inches the same when pushes roll over, because we found that when they go, that the boards kind of shift a little bit with the tire inner tubes, and so the spacers kind of keep the 2-inch spacing consistent there. And so the FitMate Pro. So this is the FitMate Pro unit. It's a portable machine that performs metabolic assessments. So PTs, athletic trainers will use this to test out athletes and see if their max heart rate, how much energy they're pushing out when they're working out. It's used in clinical athlete and exercise testing. So what we're going to use it for is to measure oxygen consumption and heart rate. So each participant will wear this mask over their face, and it'll be connected to this unit through a respirator. And while they start the test, it'll measure how much oxygen they're breathing in and out over the test, and it'll graph that for us as well. And each participant is also wearing a heart rate strap, and so at the peak of their exercise, we'll see how much their heart is working and how much oxygen they're using to push each one of these wheelchairs over each of these surfaces. So that's going to kind of tell us how hard they're working to push each wheelchair, and whether they're using more effort to push this one or more effort to push that one is really going to help us determine which one of these wheelchairs is better over a rough and smooth surface. Why are we doing this? We're trying to give feedback to manufacturers to make these chairs better for people who don't have access to PowerRise wheelchairs. So if we find, say, that we can improve this wheelchair by maybe getting rid of this big caster wheel or changing it or making it bigger, something like that, we can give feedback to the manufacturer and say, hey, people are really having trouble pushing this wheelchair over these surfaces due to their comments they put on their comment sheets that they said. And also, we're trying to see, aid in future studies, so if people look back and say they're trying to do something similar to us, they can make it better, or they can change it and see what we did, and then it'll just kind of help them really aid people who are on wheelchairs and just kind of bring wheelchairs better to people in lower resource settings. And we're basically trying to improve the mobility provided by these wheelchairs in lower resource settings. So like Justina was saying, in Kenya where they don't have access to this stuff, they kind of get the lower wheelchairs that don't fit them properly, or they don't have money to fix the wheels. We can get them a wheelchair that will really fit their environment well for them so that they can use it and really have improved mobility and not really be struggling as much as they are in their wheelchairs right now. And these are some pictures. These are all the boards that we had to make by hand. Cut them, bevel them, staple each one of these tire inner tubes on them. I think it's 96 boards total. This is us stapling them to the PVC pipe. More stapling, more more stapling. This is me cutting. This is for the spacers. We used smaller PVC pipe, cut it to 2 inches, and put it between each gap. And this is some of the team right before we started doing all the construction on the rust units. And now Karen's going to talk to you guys a little bit about Kenya.
Hi everyone, I'm Karen Gula and I am a freshman biology major. And I'm going to talk to you guys a little bit about researching abroad in Kenya. As Justina said, every year since 2010, Mrs. Berkman has been able to bring members of the WheEls team with her to Kenya. And while they're there, students get to not only perform further studies, collect more data, and do more research, but they also get to interact with some of the kids that their research impacts, and that's a neat experience in itself. Ultimately, the reason why we go to Kenya is to serve others. We are a Christian undergraduate research team, and so whatever work that we do, we want it to be done to the glorification of God. And so whether we are collecting data, whether we are building recipes or validating a questionnaire, we want that to be to serve God. And that is exemplified whenever we go to Kenya. Students there get to be able to bless the children there with their research and also share Christ's love with them. And I think that ties well into what Matthew 25:40 says when Jesus tells us that whenever we serve others, whenever we bless them with what God has blessed us with, we are ultimately serving Him. And it's really cool that as undergraduate research members, we get to change the world and make a difference in the world while we're in college. We don't have to wait to go out into the real world to do that. We can do that now. The kids that we work with go to a school called Joytown, and they work with Bethany Kids, which is the rehabilitation center there, as Christina mentioned earlier. And since 2010, they've been providing therapy to the kids there. And before then, they were able to provide surgery for children who have spina bifida and hydrocephalus. And both of those are disorders of the central nervous system that cause children to be placed in wheelchairs long term. And so these are some pictures of the kids at Joytown. And the man that you see in the middle that's he's reading something, he is the founder of Bethany Kids. Dr. Rick Bransford. He founded Bethany Kids in 2001 and then brought over to Kenya in 2004. But he's done a lot of work prior to that. He named it after his daughter and is a general surgeon who became a neurosurgeon somehow because he was able to perform so many brain surgeries during the duration of his career, which is really cool. He's done a lot of great work for people in the world. And we were able to meet him and his wife at a conference we went to last semester. And you can just tell by talking to them that they love God, that they love people, and they really want to make a difference in the world. He's retired now, and so there's a new director of Bethany Kids. We were able to meet him at the ISS conference we went to in Nashville, Tennessee a month ago. And so this is a study that we did in the past in Kenya, which is on the maintenance condition of the chairs, and that's basically what Brandon is doing, which talks about how the chairs can be upheld there. And we did a study obtaining feedback from the seating specialist on the suitability of the chairs, so got feedback from the physical therapists and occupational therapists on how well the wheelchairs fit the kids there. And we also got feedback from the users on the components of the chairs, like how Sonia was talking about. They will test the seating, seat cushions, and the head support, the harnesses, casters, and things like that. We got the users' feedback on those things, and we got their feedback on the functional mobility of the wheelchairs. So now Melanie's going to come talk to you guys about her experience in Kenya.
Hey guys, thanks for coming. So my name's Melanie and I'm a junior biology major here at LeTourneau, and I was on the WheEls team like these guys for my entire sophomore year of college, and then I went to Kenya last summer with Ben and a couple other people. So I'm going to talk to y'all about reasons why going to Kenya is a major check off your bucket list. And this isn't just that, it's also a summary of all the reasons why I love WheEls and why I'm still involved with WheEls, even though I technically graduated and I'm an alumni. I'm still involved, and it's because I love this program, and it's for all these reasons. So starting with the first, which is undergraduate research opportunity, and y'all been hearing about this the entire time, about all the different studies that WheEls does and all the different things that we're able to do, all the different projects that these guys are working on. It's a really fantastic opportunity to get involved in actual scientific research that makes a difference, and then take it on further. So that's another thing that you've heard about is Ben went to a conference this last weekend, and a bunch of us went to the International Seating Symposium in February, and I was able to present my paper, or present the study that we had worked on, and write up that paper, and the data that we gathered from ISS. Now I'm able to work with Mr. Spin and be able to write up that data, and so you get the experience of scientific research, and then even beyond that, you get to see where does it go from that. After you finish the research, what happens? You publish it, and you use it to make a difference. And so that's the goal. So So you have that opportunity. Travel and exploration, obviously, you get to go to Kenya. We all do our own fundraising and send out support letters and all that, raise money to go to Kenya. And I mean, if we say we want to go, we make it work. I mean, God provides every single time. And so we get to travel to Kenya. Not only that, we stop off in London on our way there. We spend a couple days there sightseeing, and so it's fun for us too. It's not all work. Application of what we study. In every science class you're ever going to have, people are going to tell you, okay, well, what is a hypothesis? And, you know, what do you do? How do you collect data? And make sure, you know, that all your experimental variables are in control and stuff like that. And those are all very important things, and we can see through wheels that how important those things are. So we make hypotheses in wheels about the wheelchairs and what we think they're going to do and how they think we're going to perform. And guess what? It's real life, so we might be wrong. We've been wrong before, and that's why we do the tests that we do, to see what the results are. We don't do them to prove ourselves right, we do them to make a difference. During the studies, it's easy to make mistakes, and I've made some myself that have, different studies that have made the data not usable, and that's a real life application of something besides what's in the controlled laboratory environment like we have over there. Excuse me. So everything you're learning in classes as a science major especially, and even as an engineering major and kinesiology major, gets applied during the WHEELS program. Full Canyon experience. We do a lot of things in Kenya. I'm going to show you all some pictures in that. We don't just stay at Joytown the whole time. We go for trips on the weekends and climb mountains and get kissed by giraffes, and it's a blast. I'll tell you more about that in a minute. But most importantly, we make a difference in the lives of others. WHEELS has impacted me a whole lot, and I think anybody who's been on the team can say it's impacted them as well. So it changes our lives, but it changes the lives of other people too. It changes the lives of the kids we work with. Just being there and being able to love on them while we're there and showing them that someone cares about them and wants them to have a full life, as full as they possibly can, means the world to them. And the people who are with Bethany Kids, the therapists and stuff like that, we're going to help them. We're going to aid them, give them the support they need, help them where we can. There are only a few people and they do a great job, but they can't do everything. And so we try to help them. And we also try to help the manufacturers who make the wheelchairs. All of this research that we do, the feedback gets sent to the manufacturers, and with the goal of helping them improve their wheelchair design so that in the future, kids can benefit even more from the chairs. They talk a lot about how kids in Kenya don't have power chairs, and we do so much study with the ease of pushing, because the easier it is to push the chair, the more likely it is that the kids who are in wheelchairs will be able to get out of the house. And that's just, I mean, it's a lot harder when the terrain is rough and when there's not wheelchair ramps and stuff like that to get kids out. And so the easier the chairs are to push, the fuller lives, more full lives they will have. All right, so here's some pictures. You've already seen some from our data collection. There's Elisa and myself doing some of the skills tests, and Luke up top over there working with the FitMate units which we took to Kenya. Chris Reisling, who's the top picture up there, he's a physical therapist that came with us and did surveys with the kids. And over there, that's Austin McCassam, who went to Kenya with us last summer, and those are the kids in the preschool. We don't do wheelchair testing with kids in the preschool because they're preschoolers, but they have a little section to themselves, and so we're able to go over there a couple times and play with them. And let me tell you, if you sit down, they're all over you, just like that. And then these are some of the outside of Joytown adventures that we had. We went and climbed Mount Longonot in Kajabi, Kenya, which is a picture up top. We visited elephant and giraffe sanctuaries. Got to pet baby elephants and get kissed by giraffes. And we went to, ironically, an Ethiopian restaurant while we were in Kenya and got some ethnic food. And chimpanzee sanctuary, that's me. We went and visited the high school that Mr. Spin went to, Rift Valley Academy, that has a playground. So because we could, we played on the playground, and it was fantastic. And this is a picture from London in front of Big Ben in the Houses of Parliament that the girls took while we were there. So like I said, it's a full, not only a full Kenyan experience, but just a full traveling experience. So yeah, you should go.
So is any of that side appealing to you guys, whether you're interested in like the technical side of wheels, or whether you're interested in wanting to help people? I want any of you guys to apply. We take anyone of any major, just as long as you have a heart to serve and as long as you're willing to do the work that it takes to be part of the team. We'd love for you guys to apply. The deadline to apply for the fall term of 2015 is 2 weeks from tomorrow, Friday, April 10th. And if you guys have any more questions, you can contact Mrs. Rispin. This is her email. she has an office in Glasgow, so you can stop by her office and ask her questions there too. But we want to thank you guys for listening, and if you guys have any questions at this time, you can take them. And I really keep picturing you, Danielle. So, questions?
So why did you choose these two particular wheelchairs to test?
For the semester,
Yeah, we use these because I think these are pretty average seeing chairs. These are big manufacturers that send a lot of their chairs over to Kenya and places like that. And so if we use one of the chairs that we use mainly, it's like a chair that's actually going to be put into work in Kenya. So it's a chair that's going to be that the kids are going to be using and pushing. So these are going to go to the manufacturers. They're going to directly help people in low resource settings because they have access to these two types of chairs. Especially Hope Haven, they send a lot of chairs out to kids in low resource settings. If you have anything else to add to that?
The motivation chair was designed in the UK and built in China, distributed around the world. This one was designed in the US, built in Guatemala, and distributed around the world. And both manufacturers are very interested in what we find out.
Yes.
Now, from what Sonia presented, I see that you went out with different wheelchairs which have maybe different ages, and I see like comments like the cushion was worn out and they end up giving the wheelchair maybe a lower grade. I'm assuming that that's not fair. Or what would the purpose of choosing wheelchairs of different ages rather than maybe new wheelchairs to
Yeah.
compare so that people
So-
can evaluate them at the same age rather than...
We want to measure the condition of a wheelchair, so we cannot measure if it's broken, if it's a new wheelchair. So we try to put a wheelchair that it was very old, probably 10 years old, and it was really bad. And then this one that had like 2 months of use, and then another one that was kind of not new, but it wasn't really used. So we try to measure if it was a very bad wheelchair, they had to rate it bad because the condition was not good. It was not functional. It was not able to use it for the purpose that it was.
So in that case,
Our purpose was to validate the questionnaire in that case, not to rate the wheelchairs. When we use that questionnaire in Kenya, the wheelchairs are of a known and similar age.
okay.
Well, if there's no more questions, we'll be closing out. You can certainly visit